All right, so lecture 4.4. All right, so this is laws of logarithms. Okay, we have a bunch of laws up here. Hopefully, though, you have seen these laws before in either Math 103 or in your previous mathematics classes. Okay, so I'm going to give you time to review these by yourself. We're going to go forward solving. All right, so example 1, we're told to evaluate. Okay, so evaluate is not necessarily solving because notice we don't have any equal sign, so it's not an equation. Evaluate, we're just trying to find the answer. All right, you know what I'm going to do? These are all the same base. Notice that? That's base 3, base 3, base 3. Bloop, bloop, bloop. So I'm going to go ahead and use the subtraction rule in a sense. But actually, if I went and used the subtraction rule, because notice the subtraction rule turns into division, I'd end up having like a complex fraction. So I don't want to do that. So I'm going to use a trick. Okay, this is a trick I was taught by my own, I think it was my 135 teacher. All right. Okay, I'm going to instead make this into a multiplication problem. Okay. Okay, so I am rewriting this so that it's a -1 times my log and addition. Okay? And I'll show you why I use this trick. Okay, once I do that, I'm going to use the exponential rule and bring those -1s up into the exponent. Okay, so using that exponential rule, I can bring this up and be the exponent of my argument. And now they are all addition, which means I just multiply. I don't have to worry about which number is going to be divided by which number, okay? So the reason I tried to avoid the division is because sometimes we have so many numbers being divided, it's hard to remember who's divided by who. All right, so because of all the addition, see the addition going on? I keep the log, and I will multiply, all of the arguments together. So that 100 multiplied by the 18 to the -1 multiplied by the 50 to the -1. Okay, now once I do that, though, however, I see these negative exponents. I'm not allowed to leave my answer with a negative exponent. So I'll take the reciprocals of those, and I have 100 divided by 18 times 50. All right, let's simplify. Zeros cancel. 5 can go into itself once, and 5 can go into 10 twice. Then 2 can go into itself once, and 2 can go into 18 9 times. So I'm left with log base 3 of 1 over 9. So this is saying 3 raised to what power would give me 1 over 9? Well, that would be -2. So the answer is -2, and I ran out of room here. All right. Okay, so my answer of -2. All right, so however, when I look at B, notice my bases are not all the same. So I'm not going to use the method I used here. Instead, I'm just going to see, can I simplify each logarithm individually? Well, this is saying 3 raised to what power gives me 27. Do I know that? Yeah, 3 to the 3rd power. So this is going to be 3. So I simplified this one into 3. Minus, let's see, 3 raised to what power gives me 1? 0. So that turns into 0. Bring down the negative again. And this one, this is saying e raised to what power gives me e to the 3rd power? Well, a third. All right, so then this is going to be 3 minus a third. The 0 moves. Or sorry, the 0 cancels out. And now I have the subtraction of two fractions. So I'm going to go ahead and use the building up property. Make a base of 3. So then I have 9 over 3 minus 1 over 3. Subtracting, I get 8 over 3 as my answer. All right, so notice this one we could combine it all because they all had the same base. This one we could not. These two had the same base, but this one did not. All right, now, next we have a different version. We're asked to expand. Okay, so expanded form, we have to make sure that there's no multiplication in the arguments, and that there are no exponents on any of my variables. Okay, so no multiplication and no exponents. So that's going to be my checklist. No multiplication, no multi or division in argument. This is for expanding. And 2, no exponents. That's my checklist. So at the moment, I have a bunch of multiplication going on. Look at all of that. And I have exponents, okay? So I know I need to get rid of those. So first, I'm going to rewrite this. All right, in order to get into my argument, I need to remove that exponent. So I'm going to bring it out front, multiplying it to my log. All right, so you have to be careful here because that 1/3 is going to be multiplied to whatever this log expands into. All right, so let's go ahead and expand this logarithm. It's all multiplication. It's going to be 1/3 times whatever the expansion is. So log base 5x plus log base 5 of y. So wherever there was a multiplication, that is where I split my logs. Okay, and notice we still have the 1/3 times this whole quantity. Be careful with that, okay? That's sort of a common mistake I see happen on students' work. They forget that 1/3 is supposed to be multiplied to everybody. All right, okay. Well, let's see. Checking, do we have any multiplication or division in the logarithms? Or in the arguments? No. Do we have any exponents? Aha! That exponent right there. We got to get rid of you. So we're going to bring you out front. All right, and last things to do, multiply that 1/3 out to everyone. All right, so then we get 1/3 log 5x plus 1/3, log 5y plus 2/3 log 5 of z. All right, okay, let's see, our checklist again. Do we have any exponents on our argument? No. Do we have any multiplication or division in the arguments? Nope, we're done. All right, so let's go ahead and take a look at B. Do we have any multiplication or division in the argument? Yeah. That division and that multiplication. And do we have any exponents on our variables? Yips and yips. Okay, we got a lot to do. Okay, let's go ahead and first expand this out with the subtraction. Okay, let's see. This one is simplified. There's only a and there's no exponents. This one, however, still has that multiplication going out and that exponent, or both of those exponents. So we're going to do natural log of a minus. Now be careful. Once again, this minus is going to apply to whatever this simplifies out to. So I'm going to go ahead and put my parentheses. So that's going to be natural log of b cubed plus natural log of the square root of c. Okay, but I'm going to multiply out that negative because it's supposed to be applying to both of them. So that's going to be natural log of a, what was that? Okay, minus natural log of b cubed minus natural log of, whoa, I don't know what I did there. That is supposed to be a c. And I'm going to change that to a half power. All right, so pull out my checklist. Any multiplication or division in the arguments? Nope, nope, nope. Any exponents? No. Ah, yes, and yes. Okay, so our plan, bring those exponents out front, and then it'll be fully expanded. Oops, that 3 just wants to come out for some reason. Okay, and there we go. Our checklist is done. Oh, and I forgot to box my other one, so I'm going to go ahead and box this one as well. All right. Okay, good. Okay, so next, let's see. Okay, so this time we're doing the exact opposite of expansion. We are combining. Okay, so our checklist is going to be the exact opposite of our expansion. We want to make sure that there is no, so for combining, 1, no addition or subtraction of logs, and 2, all, let's see, coefficients of the log are turned into exponents. Sorry, my handwriting's looking really ugly. All right, so for example, what do I mean by this? Well, if we have that, we want to change it where the coefficient is now the exponent, okay? So we're going the exact opposite of what we just did. Okay, kind of like an accordion, expand and contract, okay. So first things first, I want to get rid of the addition and subtraction. But we have 2 subtractions here, so because I'm sort of wary of doing too much division and forgetting who's dividing what, I'm going to do my trick of turning all those into negative exponents. If you don't do that, that's perfectly fine. This is just the way I like to do it. And before we do this, I need to check. To do the expansions, they all need to have the same base. Are these all same base? Yeah, they're all base 3. Okay, good. All right, so I'm going to do the condensing. All the additions are going to turn into multiplication, so we keep the log base 3, and we multiply. Ooh, wait, can't do that. I jumped the gun there. Why can't I do that? Because I need to have it as a log with a coefficient of 1. That does not have a coefficient of 1. I forgot a step. Got to bring that negative 1/3 up. So I negative third and bring up the negative half. Okay, once I do that, then I have a positive 1 coefficient in front of my log, which then means I can condense it, okay, because you need that positive 1 coefficient in front of your logarithms. All right, so now I can condense it. So all that addition becomes multiplication. Okay, once I do that, last thing I need to do, actually, got a few things. These are both base y. Okay, so I can combine those two. So I'm giving them the same denominator, that's going to be 6/2. Adding that, that's going to be log base 3 of x to the y, and that's going to be negative 7/2. Okay, but we can't have a negative in the argument, or sorry, we can't have a negative exponent. So we're going to take the reciprocal. And there we go. It is now condensed. So we can check our checklist. So there's no addition or subtraction of logs, check, and all coefficients of the logarithm are turned into an exponent. Or another way of saying it, the coefficient of our logarithm is a positive 1, which it is, check. Alrighty, let's see, here we go. Okay, we've got a 2 coefficient, a negative coefficient, and we've got addition and subtraction. So I'm going to go ahead and change those, bringing those all up to the front, or up in the exponent, excuse me. So that'll be the natural log of a squared plus the natural log of a plus b squared plus natural log of a minus b. Sorry, that was a negative 2. Negative 2, I have no idea where that came from. I was supposed to be a negative 1. Sorry, bringing up that negative is going to be a negative 1 exponent. All right, and then now, because all the coefficients are positive 1 in front of my natural log, I'm going to go ahead and multiply the arguments. Okay. Last thing, we can't have that negative in our exponent. So we'll bring that down to the denominator. And there we go. There's a positive 1 in front of my natural log, and my argument is condensed. So, voila, we are done. Okay, so we have this change of base formula. So the reason we use the change of base formula is because, as I mentioned before, or as hopefully I have mentioned before, that on our calculator, if you pull it out, and what happens on most calculators that you pull out, the only options you'll have is log or natural log. The only two options for your base are base 10 or base e. Some of them, like this one actually, is fancy and you can choose other bases. But oftentimes, if you just pull out any random calculator, the only options you have are base 10 or base e. But sometimes when we're solving, for example, we get a base 3. But my calculator doesn't work with that, so I'm kind of stuck. Well, what we can do is this thing called the change of base formula. So if we had a base 3, for example, we could finagle our way and create it again with a base 10 or a base, so base 10 here or a base e here. Okay, so this is useful, so very useful if your calc has only base 10 or base e. Okay. But here we go. This is going to be the proof. Okay, so let's say we have log base b of x equal to y. All right, let's say I have that. I'm going to change this into exponential form. So that's going to be b to the y power equals x. And then I'm going to go ahead and take the log of both sides. So log base a of both sides okay, and then using the exponential rule, I'm going to go ahead and bring that y out front of my log. So this will be y log base a of b equals log base a of x. So we want to solve for y. So dividing both sides by log base by log base a of b. So I solve for y equals log base a of x all over log base b, a of b, sorry. All right, what am I doing? Well, hey, notice this is exactly what we had here. But I have it equal to y, not log base b of x. And I'm trying to show that log base b of x equals this amount. But what do we know about y? Y is equal to log base b of x. So I can just use a simple substitution. Since y is equal to that amount, well, I know they're the exact same thing. And is this what I was trying to prove? Let's see. Log base b of x equals log base a of x divided by log base a of b, which is the exact same thing here. Okay, so I have proved the change of base formula. And let's go ahead and use an example on actually using the change of base formula. All right, so suppose I have solved, and I have no idea what that was. I have log base 5 of 62. But here I am with my sad calculator, and I am stuck. I only have log base 10 or the natural log. That's a base 5. What do I do? Well, we have the change of base. All right, so let's see. According to this formula, my base is b, so I'm going to say base is b. So b equals 5. And my x value here is 62. And let's see, sadly, I cannot take a vote in class by what base you guys want, so I'm going to go ahead and just choose natural log as the base we're going to go with. Okay, you could choose base 10. So I'm going to change this and recreate it. I want log base. What did I say I was going to do? I'll just go with natural log. Common log. And now according to my formula, x will be the new argument on the top, so that was 62. And b will be the new argument on the bottom, which is 5. And there's my change of base. Okay, and then we're going to go ahead and calculate this. And we're going to round to 4 decimal places. So pulling up my calculator, Let's see. We have log base. Okay, so that's going to be regular log. Let me pull this up. Okay. That's going to be log 62 divided by log 5. And what is our answer? 2.564. And we're just rounding to 4 decimal places, so we're going to go with 2.5643. All right, and there we go. That is how we can apply the change of base formula to easily use just the base 10 or base E. All right. Oh, and that was it. Here's your written homework. Due by the end of the week. Please email me if you have any questions.